All right, so here's our problem. Number one for test three. These are from the sample problems, um, and of course, test three's part B is going to be um, very similar to these problems. All right, so the first one says, how long does it take in hours for sunlight to reach A, Pluto, or B, Uranus? The average distance between the sun and Pluto is 39.5 AU, and 1 AU is 150 million kilometers. Excuse me. Uranus is 19.8 AU from the sun. We're going to round the final answer to one place past the decimal. And of course, sunlight is electromagnetic radiation, radio waves, visible light, infrared, all of that travels at the speed of light. Um, all right. So what we're going to do is we're going to say the speed of light is the distance that something travels divided by the time it takes to travel. And really what we're looking for is t. All right, so I'm going to rearrange this equation and solve for t. All right, so and this is in the formula sheet as well. The final answer solved for t. So if I multiply both sides by t, right, the t's cancel on this side, right, and so then this entire thing become. I'm just going to clean this up a little bit. Is t times c is equal to d, and so what I'm going to have to do is to isolate the t, I got to divide both sides by c. And so this is basic. These are basic algebraic manipulations. All right, so t is d divided by c. All right, so that's really what we're looking for. T is the distance divided by the speed of light. Now they give us the distances in astronomical units. Yeah, and so what we're going to do is we're going to convert the distances from astronomical units to kilometers. All right, so and then we'll use the speed of light as 3 times 10 to the fifth kilometers per second, which of course is what the speed of light is. Um, all right, so here we go. So for part A, all right. So for part A, the distance is 39.5 AU, and we know that in 1 AU, right, remember I got to cancel the AUs. It's 150 million, which is times 10 to the sixth kilometers. All right, so there we go. So the AUs cancel, and here, let's get my calculator. Let's clear that. All right, so here we go. So 39.5 times 150 150 times 10 to the sixth. All right, and so that's this number. It's not given to us in scientific notation, but it's like 5.925. Let's see, times 10 to the. So the decimal point is right there. So that would be 1, 2, 3. There's 6. So 9. 5. So it would be 5.9. 5.9. Oops, 9. That's supposed to be a 9. Sorry. 9. 25. Yeah. What was it? Times 10 to the. I already forgot what it was. 5.925 times 10. So this is 1, 2, 3, 6, and 9. Times 10 to the ninth. E9. All right. Times 10 to the ninth kilometers. All right. So that's just changing this distance into kilometers. All right. So now we're going to use this equation right here. And so for part A, the time to get for sunlight to get to Pluto is going to be 5.92, which is in my calculator in the not in scientific notation, but it still means the same thing. Times 10 to the ninth kilometers divided by, and so the speed of light is 3 times 10. it's normally 3 times 10 to the eighth meters per second, but since we're in kilometers here, it's 3 times 10 to the fifth kilometers per second. All right, and so now the kilometers will cancel, and you get 1 over seconds, and so the answer comes out to be seconds, and then we'll convert it into hours. All right, so here we go. Let's see. So this, where's my calculator? It is. All right, so there's the distance. It's not in scientific notation, but that doesn't really matter. Divided by 3 times 10 to the fifth. All right, so this is the number of seconds that it's going to take. All right, and then so 19,750. So 19,750 seconds, and then we say in one. Well, there are 60 seconds in 1 minute. Remember, use MIN for minute. And then there are 60 minutes in of course, 1 hour. All right, so the minutes cancel, the seconds cancel. All right, so you just basically take this 19,750 divided by 60 squared, right? Because that's what's in the denominator right there. And let me get my calculator. All right, so I'm just going to divide by. You could divide by 60 and then divide by 60 again, or just do both of them at the same time. Divide by 60 squared, and so see the answer right here is 5.5. So that's what this should come out to be. So I'm going to round it to one place past the decimal. So it's 5.48 since the hundredths place is the 8 right here is greater, it's 5 or greater. I round the 4 up. Right, so this becomes 5.4. Well, sorry, 5.5. Sorry, 5.5 hours. All right, let's do part B. All right, so part B, it's basically the same steps, but now you're using 19.8 astronomical units. All right, so here's part B. So it's 19.8. That's the average distance between the sun and the planet Uranus. And so we just say, all right, well, in 1 astronomical unit, 1 AU, there are 150 million. And so 150 times 10 to the 6th kilometers. All right, just like we did in the last problem. So that's converting it. So 19.8 times that. Here, let's get our calculator. So 19.8 times 150 times 10 to the 6th. All right, there we go. All right, so that's the number of like 2.97. And what would that be? That would be 2.97. 1, 2, 3, 1, 2, 3, 1, 2, 3. All right, so times 10 to the 9th. 2.97 times 10 to the 9th. 2.97 times 10 to the 9th kilometers. And just like we did with the last problem, the time is the distance divided by the speed of light. So it's, this 2.97 times 10 to the 9th kilometers divided by 3 times 10 to the 5th kilometers per second. And the kilometers cancel, and that'll give us an answer in seconds. Let's see, here we go. All right, so we just take that, divide it by 3 times 10 to the 5th. All right, so that's so it would be 9,900 seconds. 9,900 seconds. All right, and then we just do this thing. Of course, 60 seconds in 1 minute, and there's 60 minutes in 1 hour. All right, so so we just take this number that's already in my calculator, 9,900, which is right there, and we just divide that by 60 squared. Divided by 60 squared. All right, so and there's the correct answer. So the number of hours it takes sunlight to get to Pluto would be 2.75. So it would be 2.7, that's a decimal, 5, and it's hours. All right. Remember, in Blackboard, you only write the number. All right, you don't write like the problem would just say how many hours does it take. You just put 2.75. All right, very nice.